Hi everyone. So I'm going to talk a little bit about opinion polling. I know this is probably something some of you are interested in. I am not an expert on this, but I have a little experience or a little bit of knowledge, and so I'll share what I have and maybe get you started towards finding out more. Um, so. Uh, Opinion polls. So I'm gonna So what are they? I mean, this seems like maybe a silly question, but I want to distinguish them from the kind of surveys we've talked about before, which are scientific surveys. And so I'll talk about that. I'm going to talk about sample selection. We talked about some of this before with regard to experiments, and so some of it will be repeat, um, but I'm going to try to make it as it applies to polling. um, Sample size. And so that's going to be one of the last things I'll talk about. How big do the samples have to be and what determines it? Um, so to start with, what are opinion polls? What are we actually talking about here? Uh, we're talking about a survey of public opinion from a particular sample of the population, and this is not for scientific purposes. I mean, we could survey public opinion for scientific purposes, but what we're really talking about here are things that are done for purposes of, they're done by campaigns, they're done by news organizations. They're trying to get us, um, they're trying to get us public opinion on things like political candidates, public policy. Sometimes they're on things, though, that don't have much to do with politics, things like consumer products. They can also be public opinion on things like social issues. So it has application beyond just our field of political science. And it may be one of the useful things that you can do with a political science undergraduate degree, a bachelor's degree in political science. Um, and and what's important is that opinion polls are snapshots at a moment in time. So opinion polls are not, uh, we often think of them as being for forecasting, but it's important to realize that opinion polls are a snapshot of what the public thinks at a particular moment. And if that particular moment is 6 weeks before an election, that's I'm not saying it can't be useful for forecasting the election, but the opinion poll by itself, the model for the opinion poll, is not designed to tell you what's going to happen 6 weeks down the road. The model is to tell you what is in the public's mind today. Even an opinion poll taken a week before the election doesn't tell you what's in the public's mind on election day. So um, Sample selection is extremely important in opinion polling. It's the thing that makes or breaks opinion polls, along with actually being able to get to your sample, which is the new hard part. Um, Random sampling is the best way to ensure a representative sample. Uh, in the perfect world where you somehow had the inside line to be able to talk to everyone you wanted to talk to at no cost, or you had an unlimited budget, you would want to use pure random sampling. This could be random digit dialing. Um, well, another way of sampling selection is random digit dialing. Um, Online surveys uh, are one way that samples are selected. In-person interviews can be used for sampling. Mail-in surveys or mail-out surveys actually are sometimes used. So public opinion polls should use random sampling or probability sampling. And ideally, so here are four of the types. We've got random sampling, stratified random sampling, cluster sampling, and systematic sampling. Random sampling is the simplest and probably the hardest to do. The others are variations on random sampling. Random sampling is the gold standard. It is where every member of the population has an equal chance of being selected. If you had the way to reach every member of the population, this would be what you would want to do. If you had ways to reach them and the budget to do it, the resources to do it. But this can be difficult and expensive to implement. Many people can't be reached by any method other than literally going and finding them. And many people are hard to find, intentionally or otherwise. So it can be difficult and expensive. It may be impossible to achieve in practice because of non-response bias, because people specifically don't want to respond, and other issues. And sampling of bias can still occur even with random sampling if certain groups are systematically excluded from the sample. For example, landline phone surveys, random samples of landline phones exclude younger voters. Of course, you can argue that's not a true random sample, but that's the issue. You have to make sure that there's not some systematic exclusion that's unintentional, that's preventing it from being a true random sample. Stratified random sampling is one way to get around some of the issues with random sampling. Stratified random sampling involves first dividing the population into subgroups or strata. And these can be based on things like age or gender or ethnicity, things that you might want to be sure to include. They can also be based on things like geography. So you can want to, which also would be things that you might want to include. So you might pick strata geographically in different parts of the United States if you're doing a national survey. Lots of different characteristics that you might want to make sure are included. Once you've done that, so you have the stratum, you have the group. In the group, you pick from the group randomly the number of people that would be in proportion to their representation in the population. So you've got one group that's 10% of the population, another group that's 25% of the population, and so on. You need to select from each group the amount to have the right number for the population. This ensures that the sample's representative of the population on whatever those key characteristics are that you want to make sure to include. If you still do the random part within the sampling, as long as you're not systematically excluding other groups, this still is random sampling, and it still should give you the benefits of the random sampling while also making sure that you catch everybody you want to catch. Where would be the problem? Well, the problem would be if you select based on age and you leave out Gen X, because that's what the TV networks do. They talk about the boomers, they talk about the millennials, they talk about Gen Z, and they're even talking about Gen Alpha now, and then eventually they'll be talking about the next one. And just regularly they leave out Gen X, which is just weird. But hey, it happens. I'm not bitter about it at all. If you did that though and you were doing polling, it would be a serious issue. I mean, it's a serious enough issue to some people when the news agencies do it. And I guess if the news agencies are doing polling and somehow they manage to leave out people from, 48 to 62 years of age or whatever it is, that would be an issue. So the key is you've got to make sure you catch the whole population, that you're not leaving out some group. If you do it based on ethnicity and you leave out an ethnic group, that's a problem. If you do it in order to make sure you're including all the ethnic groups, that's the good side of it. Cluster sampling is like stratified sampling turned on its head. In cluster sampling, the population is divided into clusters and then a random sample of the clusters is selected, and everybody in the cluster gets surveyed. So you might pick across the United States 100 polling precincts, 100 voting precincts, and go interview everybody in the voting precinct. That would probably be way too big. That would definitely be way too big. Because that would be hundreds of thousands of people. And you don't need a sample size anywhere near that big. You might pick several zip codes and interview everyone in those zip codes. There have been public opinion pollsters in the past who have suggested that there are certain counties in the United States, and this wouldn't be cluster sampling because they don't interview everybody in the county, but that there are certain really representative counties in the United States, and so you could do some kind of sampling in that way, where you go to just those most representative polling precincts and get a hold of everybody that you can. Um, so this is stratified. This is stratified turned on its head, because you don't randomly select the people. You randomly select the clusters. It can be more cost effective and easier to implement than random sampling. If you have a large, so like if you have a country the size of the United States, you can focus geographically. Um, the big issue is if you don't get representative areas. So especially if this is geographic clustering, you've got to get clusters that are really representative of the whole population. So if you can find that voting precinct where it matches the United States on all the demographics, and it matches the United States as a whole on party membership, and it matches the United States as a whole on income and everything, and you go and you just survey everybody there, can you get a pretty good idea of what's going to happen for the United States as a whole? Well, yeah, probably. Um, but if you pick 4 counties at random, uh, then you are probably going to not do very well. If you just say, well, we're picking 4 voting precincts at random from the whole United States and we're going to interview everybody there, you're probably going to have a problem because you can't really, uh, especially if your cluster is the size even of a voting precinct, which is a couple of thousand people, interviewing everybody in even a few voting precincts is actually much more expensive than just randomly sampling from the whole country, because you don't actually need that many people, which we will get to shortly. So then systematic sampling. Systematic sampling is really just a way of doing random sampling when you don't have a good random number generator. You pick a random starting point. If you need one person in 100, you pick a random starting point. Maybe the 13th person in the phone book, and then every 100th person. Except we don't really have phone books. We don't really have residential phone books anymore. But this is how it was done when everybody had landline phones, and when people had landline phones, you had to pay extra not to be in the phone book. The phone company put out a directory that had everybody's phone number, and you had to pay a fee to have an unlisted number. So you'd have that phone book, and you could pick the 13th person and then every 100th person. If you just used the regular phone book, though, you did end up leaving out anybody who was willing to pay to have an unlisted phone number. Uh, you could pick, you could start in a dialing prefix, so like 713555, and you could start with the 13th number of the prefix and then do every 100th number and then move on to the next prefix. So you could do the same thing just with phone numbers now that everybody has cell phones. But it's uh, easier to implement than actually producing a random number for each draw. Mathematically, it should be the same as random sampling as long as there's not some hidden pattern in the population. And so the issue would be that if you said, well, I'm going to start by knocking on every 100th door, and there was some way that the way the streets were arranged, maybe you ended up only knocking on corner lots. Could that be an issue? Could that be, could that cause some kind of bias? I mean, it's possible. There are reasons that people want to have corner lots. Some people like them. Some people don't. I'm not sure what the appeal is, and I even sold real estate, but some people insisted on having one, and some people absolutely didn't want one. So it would make a difference if you ended up getting a high proportion of corner lots because of your pattern. That could make a difference. Uh, this is fairly common in polling, though, because it's just easy. You only have to randomly pick where you start, and then you just go every 10 or every 100 or whatever. Um, so Gallup uses directory-assisted random digit dial telephone samples that use a proportionate stratified sampling design to contact landline and cell phone users. So you think about this, they have a proportionate stratified sampling design. So that means they've divided the country, or they've divided whatever geographic area they're polling into strata based on something, and then within those strata they randomly dial telephone numbers of people in those strata, and they specifically include landline and cell phone users. Does that make it perfect though? Well, for a long time, cell phone users all had caller ID, and landline users paid extra for caller ID. So not everybody had it. And also there was a time period when you paid per minute for cell phone and landline was free. So people were much more willing to pick up the landline than they were to pick up the cell phone when they didn't know who it was. Um, that's changed a lot now with almost everybody. Very few people pay per minute for cell phone use anymore. A few still do. Um, but and our telephone habits have lapsed over into the landline to where most people, quite a few people, just don't answer phone calls unless they know who's calling, regardless of what kind of phone it is. So, but this is the method they use. So, sampling bias issues. Polls of likely voters systematically exclude no voters because a likely voter is decided by looking at the voting records and picking out the people who have consistently voted election after election. Well, new voters that have never voted before are not going to be polled at all. And new voters who've only voted once or twice still may not be flagged as likely, even though they may absolutely vote. Polls of landline phones systematically exclude Gen X, Millennial, and Gen Z voters. Older Gen X, maybe not as much, but definitely younger Gen X and Millennial, heavily excluded from polls of landline phones. At least as a percentage, a significant percentage, a very large percentage of Gen X, Millennial, and Gen Z voters do not even have landline phones of their own, at least. Non-response bias. People who respond to polls may not be representative of the population. So that is, if you get the person who will actually answer the phone or the door, uh, in a country where people have become accustomed to not answering the phone or the door unless they know who it is, are you actually getting someone who represents the normal person? Probably not. You're getting somebody who, at least in some ways, is not in the probably not under that 68% at the center of the bell curve. So a lot of these things are determined by how big a sample you need. A lot of the talk about expense centers around sample size. But it turns out you don't need that big a sample. Sample is determined by the margin of error for a given confidence level. This is the full this is the full formula for it, and the p is the probability that we're going for, or is the sample proportion rather. It's the proportion of that we're going for. N is the sample size, and Z is the Z-score for the desired confidence level. And it turns out that the sample size that's required for is not very big. This works for things that have an obvious sample proportion, like percent of respondents who support a candidate. So it's important to remember that this margin of error works for specific things. So if you have a 6-candidate race, you can't go P times 1 minus P because there is no single P. There are 6 P's in there. It's a more complicated calculation. It's also important that this is ex post. So this is done after the poll is concluded. You input the numbers. And why is it ex post? Well, because the P and the 1 minus P you don't know until after the poll is done. So what if you want to determine your sample size ex ante, that is, before you begin? Well, we have a whole different margin of error population or calculation, and it's 1 divided by the square root of the sample size. What you will notice is that nowhere in that is the population size. The only thing of concern is the sample size. So for the ex post calculation, we need to know Z. For the ex post calculation, we need to know Z, and we need to know the relative proportions. 60% is P, 40% is 1 minus P, and then we need to know the sample size. For the ex ante calculation, we start with the margin of error, and we solve 1 over square root of n in order to get the sample size. So if we want a 3.5% margin of error, we can algebraically solve that to get the sample size that we need, and the population size does not enter into it. Gallup Daily Tracking Poll, for example, uses 1,000 national adults. It has a margin of error of plus or minus 4 percentage points. So this means they track 1,000 adults, and they get a margin of error of plus or minus 4 percentage points. Note that there are links to the Gallup work in these slides, and I'll post these on Canvas in case you want to read more about these. But really, my suggestion is just go to the Gallup site, go to the Pew Research site, although they're not just opinion polling, they do some scientific survey work too. But go to some of the big polling sites if you're interested and read about their methods because they talk about them. It's they are surprisingly open about them. Also, worth reading if you want a little more intense read is Nate Silver's book, The Signal and the Noise. That's a good source. There's all kinds of stuff out there that you can find, and if you're looking for something to do with your political science degree, this is one of the biggies.